This video, I will demonstrate how to model a volume component, that is a three-dimensional component in ANSYS software, and to do Boolean operations as well to find out the displacement and the maximum stresses. Okay, now open ANSYS APDL, click on File, change title, a 3D model. Click OK. Click on Fit View. Go to Preferences, Structural, OK. Preprocessor, Element Type, Add. In Solid, go to TET10 node. TET10 node 187. Click OK. It does not have any real constants and also give the material properties. Material models, structural, linear, elastic, isotropic, and enter the Young's modulus value. The Young's modulus value is 165 and Poisson's ratio is 0.25. So it is 165 E3 and the Poisson's ratio is 0.25. Click OK. After this, go to the modeling, create key points, not key points, it is volumes. Create volumes. So, to model this problem, first we have to understand the directions. So, for which, click on isometric view, which will give you an idea of x and y, z directions of a component. So, in this case, this is the x direction and the height is the y direction and the thickness is the z direction. So the dimensions are along the x direction it has 1000 mm, along the y direction it is 250 mm and along the z direction it is 250 mm. So block by two corners and enter the value starting point as 00 and enter as 1000, 250 and 250. Click OK. Okay. Now I have to cut the inner rectangle, the inner block. Now for which I have to understand the dimensions. The inside block is along the total length, that is it varies between 0 to 100 along the x direction, and on the y direction, that is in the height direction, it starts at 25 mm and varies up to and exists up to 225 mm. Similarly, in the thickness direction also, it starts at 25 mm and ends 25 mm before the total length, that is 25 to 225. So I am using another option by dimensions and varies between 0 to 1000, y coordinates 25 to 225 and also z coordinates 25 to 225. Click OK. Now click on Fit View. Now subtract the inner block from the outer block. So go to Boolean operations, that is operate, Booleans, subtract, volumes. First pick the base volume. Click OK. OK. Next click the inside volume. Go to next and this has to be subtracted. Click OK and OK. Again click on isometric view, fit view, or also you can click on replot. Now I have to subtract this portion. So for this, what are the dimensions? Along the x direction, it starts at 400 and exists up to 200. That is 400 plus 200. So 400, this is the starting point and 600 is the ending point. In the height case, it starts at 75 and ends at 175. and in the z direction it is throughout the length. Therefore, again create block by dimensions. In the x direction it is between 400 to 600, and in the y direction it is between 75 to 175, and in the z direction it is throughout the length, that is 0 to 250. Click OK. Click on fit view. Now I have to subtract this portion from the entire volume. So go to operate, booleans, subtract, volumes, pick the base volume, that is this, not this. Next, and the pink color is the base volume. Click OK. OK. Now subtract the smaller portion. Click OK and OK. Again click on fit view. Okay. You can see different kinds of views by using these options. Either you can see the front view, the right side view, the top view and back view, everything we can see here. Okay. But in order to get the model back, click on isometric view. Now we have to mesh the component. For which, go to meshing. You can use either mesh tool or size controls, anything you can use. I am clicking on mesh tool and I am not giving any additional conditions as well, just clicking on mesh. Which component? This is the component. Click OK. Now it is completely meshed. Okay. Now I have to apply the boundary conditions. Let us say the back side is fixed and on the top surface 200 Newton per mm. Now for which I am rotating the component in order to apply the displacement. So for which, for rotation you can use any of the keys, or also you can hold the control key and click the left button. Control key and left button. It is moving the component. Similarly, control key and left button will move the component. Center button will rotate the object. Center button. Okay. Right. Now click on the displacement. On areas, select the area. Click OK and arrest all DYF. All DYF is arrested. Now go to pressure. On areas, I am selecting this area. This is the top area. Okay. If you have any confusion which area is to be selected on the total figure, the best way is go to isometric view and go to plot controls, numbering, area numbers on. Click OK and plot areas. So that is, we have to apply the pressure on A4. Okay. Now pressure on areas, select this. A wrong area is going to select. Again select this. Okay. Click on OK. And the value is, let us say, minus 200. Click OK. Okay. Now go to solve, current LS. OK. Solution is done. Close. Go to general post processor, plot results, deformed shape, deformed plus undeformed, and go to plot controls, animate, deformed shape, deformed plus undeformed in the forward direction only. Based on the given loading conditions, it is going to behave like this. Be ensured that the value should be either negative or positive. the pressure value in which direction we have to give is very very important and is crucial. And also applying the pressure on lines, on surfaces is different. Applying the pressure on nodes is different. So applying the boundary conditions plays a significant role in deciding the results. Okay, so based on the given question, you select the loading condition and also apply the displacement accordingly. Okay, this is a simple model problem and use a solid TET 10 node element, model the component using the volumes. We have more and more number of volumes here. In the volume section also we have a block, a cylinder, a prism, a sphere and a cone, and in each case we have multiple options as well. If these volumes are also not sufficient, in order to model the problem, combine or subtract by using Boolean operations we can get the models. If the Boolean operations is also not enough and the model is complex, design that model in any one of the design softwares and transfer that component to ANSYS. Okay, right. So once you model the component or once you transfer the component onto the interface of ANSYS, go to meshing and apply the boundary conditions and loads and go for results. Okay, right. Thank you.